Hey everyone, and welcome to today's Explainer. Today we are completely deconstructing the anatomy of a single, specific math problem. We're looking right under the hood of Question 2 from the Pearson Edexcel November 2023 Paper 3H mark scheme. We're going to get right into the precise mechanics of exactly how this question is solved and graded.
Right out of the gate, I'm just going to give away the ending. The final definitive answer to Question 2 on this higher-tier calculator paper is 80. Yep, 80 expected outcomes. That's the final destination. But, in mathematics, just dropping a naked number on the page, that doesn't really tell the whole story.
Because an 80 sitting by itself on a test paper isn't enough. The real mystery is, how do you actually navigate the rigid grading criteria to earn the marks to get there? What exact steps do you literally have to write down to get full credit? Well, let's break down the required workings.
Section 1. The Question 2 Breakdown.
To secure full credit here, it is a very distinct linear two-stage process. Step 1, you've got to secure the method mark. That's where you show your underlying mathematical logic. Then, step 2, you lock in the accuracy mark by nailing the final number. Sounds simple enough, right? So what does building that calculation actually look like?
Section 2. Demonstrating the exact workings.
Okay, let's dive into this. This right here is the exact wording from the grading sheet that secures that first absolutely crucial method mark. It says, M1 for complete method, e.g. 200 times 0.4. To get this mark, a student has to physically write down a calculation proving they understand how to find an expected frequency. You have to show the total, which is 200, being multiplied by the decimal representing the probability, which is 0.4. If the examiner sees that exact string of numbers and symbols, boom, the method mark is secured.
Section 3. All possible answer variations.
Now, examiners are specially trained to look for predetermined variations, so let's look at the comprehensive list of acceptable workings straight from the source. The primary root is what we just saw, the complete method of 200 multiplied by 0.4. But check this out, it also explicitly states, or for 80 over 200 for the answer, which honestly makes perfect mathematical sense. If a student approaches this as an equivalent fraction, knowing that a probability of 0.4 is the exact same proportion as 80 out of 200, that is totally accepted as valid proof of the method.
Once that method is locked in and proven, you're going for the accuracy mark for the correct final number. The manual simply reads A1 cow, 1 accuracy mark. Now, we're going to decode what those 3 little letters at the end mean in just a second, but first, let's look at a really fascinating alternative presentation of this exact same problem.
Section 4. Modified large print adaptations.
Now, what's really interesting about this slide is the vivid contrast between the standard exam visuals and the physical adaptations made for the modified large print or MLP version. This is for visually impaired students. According to the document, the actual wording here is gets removed. The physical diagram of the spinner is heavily modified too. The spike is completely removed, the spinner is straightened up, a prominent center dot is added, and the whole thing is enlarged. Even the data table gets turned vertically, enlarged, and left aligned. It's an incredible layer of design just to ensure the exact same math problem remains perfectly accessible.
Section 5. Decoding the grading abbreviations.
Okay, to really grasp this, we need to define the specific shorthand the examiners are scribbling in the margins. First up is the M mark. The glossary defines this exactly as a method mark awarded for a correct method or partial method. That literally means you get credit for writing out the process, like our 200 times 0.4, even if you happen to completely fumble the calculation at the very end. Next is the A mark for accuracy, but notice the crucial text in the parentheses here. It is awarded after a correct method or process. It's a dependency. You absolutely have to prove the mathematical method first before you can even qualify for the accuracy reward. And finally, we have COW, which stands for correct answer only. So for question 2, there is absolutely zero wiggle room for that final number. It must be exactly 80. Not an approximation, not an unsimplified expression, only the integer 80 is going to trigger that final A1 mark.
Section 6. Core assessment objectives.
So let's zoom out a bit. The Edexcel curriculum relies on 3 core assessment objectives, and we can see the structural balance here for the higher tier papers. AO2, which is reasoning and communicating, sits at 30%. AO3, solving problems in context, is another 30%. But notice the absolute heavyweight champion for the higher tier is A01, sitting right there at a massive 40%.
And question 2 is a direct test of A01. It's all about accurately carrying out routine procedures or set tasks requiring multi-step solutions. Setting up 200 times 0.4 and calculating 80, that is the exact multi-step routine procedure this objective demands. It's the absolute foundation of the exam, which is exactly why it makes up 40% of the entire grade.
So, we've broken down the exact expected answer, the necessary calculation steps, the alternative fractional methods, and even those really cool inclusive adaptations. When you realize that math isn't just about guessing the final number, but about clearly, rigidly proving the mathematical path to get there, how does that change the way you approach your very next calculation? Thank you so much for joining me for this explainer. I really hope it gave you a fascinating new perspective on how these assessments are meticulously designed from the ground up.